In section 3.4a, we're learning to determine whether a function has y-axis, x-axis, or origin symmetry. We're also learning to determine whether a function is even, odd, or neither. So the first one we're going to look at is symmetry with respect to the y-axis. And an even function is a function that is symmetric with respect to the y-axis. And what this means is if the point xy is on the graph, then the point negative x, negative y is also on the graph. We're going to look at some visual examples of this in just a minute, but the test for this algebraically is to take the x, replace it with a negative x. If you get the original equation back when you do this and you simplify, then the answer is yes, we have symmetry with respect to the y-axis. So we're going to look at a couple of examples here. In this first example, I'm going to use the original equation. Wherever I have an x, I'm going to replace it with a negative x. And then I simplify. So in this case, if I simplify, I get negative 2. If I raise the negative to the 4th power, then that's positive. So I just get negative 2x to the 4th plus, and again, if I raise the negative to the 2nd power, then I just get 3x. So now if I compare the two equations, this to my original, I notice that I get exactly the same equation back. So what we have here is symmetry with respect to the y-axis, or we have an even function. Now let's try the second example. Again, I'm going to take out the x and replace it with a negative x. This time when I simplify, I get negative 2x to the 4th. And then if I cube the negative, I'm going to get a negative. So that changes my sign to negative 3x cubed. And I now go and compare this equation to the original equation. And you notice that we have a sign change here, a different sign. It is not exactly the same. So I do not have symmetry. I do not have an even function. I don't have symmetry with respect to the y-axis in this case. Now we're going to look at symmetry with respect to the x-axis, and this is when if I have the point xy on the graph, then I also have the point x negative y. The test in this case is to take out the y, replace it with negative y, and find out if we get the original equation back. If we do, we have symmetry with respect to the x-axis. So here we have two examples. I have a y. I'm going to replace it with negative y. Everything else remains the same. When I simplify, and I compare the two, we notice that they are exactly the same. In this case, I have symmetry with respect to the x-axis. All right, now let's try the second example. In the second example, again, take out the y, replace it with a negative y, and I get this when I simplify. So in this case, you should notice that it is not exactly the same because I have sign changes here. Those are different. They're not exactly the same. So I do not have symmetry with respect to the x-axis in this case. And then our last example is symmetry with respect to the origin, and this is also called an odd function, and that's when you take the point xy, it's on the graph, then the point negative x, negative y is also on the graph. So what that means is what I have written here. If you have f of negative x, then that's going to produce negative f of x. So for instance, let's say we have the point 2,5 or the ordered pair 2,5 that is included in that function that is on the graph of that function. Then that would also mean if this were symmetric with respect to the origin, then the point negative 2, negative 5 is also on the graph. Algebraically, the way we test that is we take out the x, replace it with the negative x, and what we want to see is all of the signs change, so exactly the opposite signs. So let's look here. Wherever I have an x, I'm going to replace it with a negative x. And then I simplify. And when I cube the negative, I'm going to get a negative. So that's going to change. That negative times a negative is going to give me, simplify as this. And then negative 5x. So now when I compare this to the original, you notice that I have an imaginary plus here. Compare that to this sign, and you notice it did change. Okay, we have another sign to compare. So you've got the negative 5x, and now you have a positive 5x. So the answer here is that yes, this one is symmetric with respect to the origin. We do have an odd function. And let's try the second one. So in the second one, Again, we're going to take out the x and replace it with negative x. Okay, and when I simplify this case, I cube the negative and I get a negative, so that's going to change that just like the last, and I get a plus 5x squared. Now I compare my signs. I have an imaginary positive here. That stays the same. Notice those are exactly the opposite. And now if I look at those two, those are exactly the same. So that one doesn't work out. So I don't have symmetry with respect to the origin in this case. It is not an odd function. Okay, now let's summarize this. So an even function is a function where if you plug in negative x, then you're going to get that same function back. And so that means symmetry with respect to the y-axis. Here I have a visual example for you. If I were to clone this, and if I flip this over left-right, so that's over my y-axis, then you notice I get the same back. And I'm just going to so now you can see that these are going to coincide, exactly the same graph. Okay, and you can tell that they're different because in this one I have this on this side and this one I have on this side. So it is symmetric with respect to the y-axis. Okay, now we have symmetry with respect to the origin. So again, I'm going to clone it. Okay, now symmetry with respect to the origin means that I can rotate it about the origin less than 360 degrees and get the same thing back. So there you notice I have rotated less than 360 degrees because you see the writing in the bottom right hand corner, and you notice that it will coincide with the original graph. So this is symmetry with respect to the origin. It's an odd function. And then the last one, of course, symmetry with respect to the x-axis. So you have your x-axis here. And if you were to fold across that x-axis, you get the same graph back, and that is symmetry with respect to the x-axis. And that's all I have for section 3.4a.